I'm pretty informal, so feel free to interrupt me, ask questions, drive the discussion in different directions, whatever you want to do. So again, I'm Aimèe Kreimer. I'm a tenured investigator at the U.S. National Cancer Institute, working in the intramural program, which means we really kind of conduct our own research, be it nationally or internationally, often in collaboration with scientists external to NIH. And today's actually a government holiday, so hence me being at home. And I've been running around because my kids are in school and so they had visitation day. So, but I made it home in time to give this talk. So I'm really happy to be here. So, let me go back one. Just want to minimize it. Okay. So everyone here knows HPV infection can cause cervical cancer and death, and this is particularly true in resource-limited countries. It is our most common sexually transmitted infection and is a necessary cause of cervical cancer. While less kind of important in the United States, it's still important, and we can talk more about that. It is the second most common cancer in some countries in Africa and remains the fourth most common cancer among women worldwide. It's responsible for over 300,000 deaths per year. And the overwhelming majority of these deaths, more than 90% of cervical cancer, happens in low and middle income countries. And this is particularly sad because we really have the tools at this point to prevent cervical cancers. I would say almost all cervical cancers. We do not need to have this cancer anymore. And as I just told you, there is still so much of it globally. We've seen now real world data that shows that HPV vaccination reduces cervical cancer by 90%. So the primary target is HPV vaccination for girls. Also, screening is highly efficacious, although it's not the most efficient, but an efficacious form of secondary prevention. However, screening programs and medical services in general for cervical cancer are either unavailable or really limited in scale. And I think there's a lot of challenges in multiple visit screening practices. Hence the focus on really trying to pull it into a screen and treat. I don't see myself as an expert on screening. I can talk the talk a little bit, but I'm not going to focus on that. I'm really going to focus on vaccination, but I'm still happy to talk screening. So a few years back, the WHO Director General put forth a global call to action. And he also said we have the tools to make cervical cancer history, but only if we make those tools available to everyone who needs them. And so the strategy has 3 pillars. It aims by 2030, so very soon, to vaccinate 90% of girls with the HPV vaccine by the age of 15, to screen 70% of women using a high performance test 2 times in their life, and then treat, and this is a key point in this strategy that often gets overlooked, treat 90% of the screen positive women who had precancer, as well as 90% of women with invasive cancer. So my last comment on screening is that a screening program is obviously only as effective as its weakest link. And so while I think the front end of screening gets a lot of attention, what's the biomarker, what's its sensitivity, what's its specificity, but then you need to bring them back, do diagnostics, bring them back, treat the ones who are positive for precancer. And that process, which culminates in treatment, screening, the screening test isn't what reduces the cancer, it's the treatment. So also very important, and I think finally starting to get really more of the attention that it deserves. So what's the goal of HPV vaccination? Why are we talking about girls age 9 to 14, girls age 9 to 14? Well, HPV, as we just talked about, is our most common sexually transmitted infection. And the acquisition is very much tied to the debut of sexual activity. So, you could always, so here's a figure that has age on the x-axis. You really could change that to time since sexual debut. because very soon after is when we see this green peak of cervical HPV infection. And then what happens is the people who have cervical HPV infection that persists, it goes on to this high-grade precancer, which eventually invades to become cancer. And so the whole goal of HPV vaccination is just to eliminate the green line. If we eliminate the green line, it's a necessary cause. We eliminate the blue line, we eliminate the red line. So it's pretty straightforward. Obviously, the implementation is harder. So HPV vaccines have been shown to be safe and efficacious for 16 years now. That's when they were approved. These are not new vaccines. We really have a good handle on their safety profile and how they work, where they work, all the details. National HPV vaccinations programs have been introduced, but global coverage remains low. And in fact, it's appallingly low. So global coverage is 13% worldwide. And so that's obviously averaging the high income countries shown in the red line with the low income countries shown in the blue line. And if we specifically think about the low and middle income countries, the LMICs, the global coverage, again, in this age range, this is, the denominator is not inflated with like all human beings or men and women. This is age, in the age range that the WHO recommends, 8%. So one more time, 8%, 16 years after the vaccines have been shown to be safe and efficacious. And there are reasons. This is an expensive vaccine. It's probably, I think giving the vaccine regimen for the HPV vaccine is actually more expensive than all the other vaccines combined in the EPI program, all of our childhood vaccines. HPV costs more. Also, the adolescent platform is tricky. We can talk more about that. So again, here is on the x-axis, we see really kind of the timeline for when the vaccines have been licensed, WHO pre-qualified, introduction, and then the number of countries that have introduced the program. And again, we see this appalling divide between the high-income countries and the low-income countries. And this is really sad because, HPV vaccination works great, in fact. So here is a figure. This is based on US data from 2018. And it not only shows direct protection afforded by the HPV vaccines, but it also shows herd immunity, kind of more than we could have ever anticipated. So walking through this figure, we see the pre-vaccine era, which is in gray. So that's like the time from 2003 to 2006. And then we see the time period split into just after vaccine recommendations came out in the US, and then like a middle period and then a later period. And on the y-axis, we see the prevalence of HPV 16, 18, and I think 6 and 11 quadrivalent vaccine types. And this is held static among women who are 20 to 24 years old, because obviously age is our biggest predictor, as we talked about, because it's linked to sexual debut, of HPV prevalence. So we see in the pre-vaccine period, the vaccine type 16, 18, 6, and 11 is about 18% prevalent. And then shortly after, we see that coming down. And again, this is prevalence. We see it coming down in 2007 to about 14%, and then it just plummets to about 3% in vaccinated women. And this is in a population survey again. This was data that came out in the MMWR. And then in the unvaccinated, we see that they probably are a riskier group. They have these very high this very high prevalence of the vaccine type. But nonetheless, as time marches on, their HPV is controlled as well, hence herd immunity. So over the next 65 years, if we kind of compute over time, we march it forward, we project out the number of cases and deaths that will be attributed, that will happen for cervical cancer. So how do they do that? They obviously take observed incidence rates, population growth, and then they kind of model it out into the future. And they did that for the high income countries, which again, we said the majority of cervical cancer does not happen there. Upper middle income, lower middle income, and low income countries. This is the estimated number of cases over the next 65 years before the age of 75. And so you see the number of cases and burden by age group. If we superimpose on that with current vaccination strategies, what will happen in terms of prevention. The current vaccination strategies, and this is a little bit old, so it would look a little bit more promising, but it makes the point nonetheless. Current vaccination strategies will avert 365,000 cases of the 19 million projected to occur and 150,000 deaths. And you see, that's because we see this disparity. Lots of vaccination in high-income countries where disease burden is low. Very low vaccination in the low and middle-income countries. We saw that 8% number where the burden is high. When we multiply that out, we see that we're averting some of these cancers in high and upper middle-income countries and nominally in these other countries. So our current strategies are unacceptable. So what are we doing about it? So we've been working in Costa Rica for a really, really long time. The NCI has been there for decades. They worked to show that HPV was a cause of cervical cancer in the 80s. In the 90s, they helped to define the natural history from the HPV infection to cervical precancer, so natural history studies. And while that was going on, Doug Lowy and John Schiller were also developing the component parts of the HPV vaccine. So seeing that the L1 capsid protein self-assembles really form the foundation. And so once the vaccines were created, NCI said we wanted to conduct an HPV vaccine trial, and this is prior to licensure of the vaccines. So it was under an IND with an investigational new drug with the FDA. Its primary aims were to look at safety and efficacy. Vaccine dogma usually starts with 3 doses. You want to do a prime, you want to do another prime, and then you want to boost. That gets the majority of the population to have an appropriate vaccine response. We used the bivalent HPV vaccine by GSK. And because this was a safety and efficacy study, we were working in young adult women between the ages of 18 and 25. So I'm going to talk a little more about design, but just kind of a big overview. We think we've really made great use of this study to drive forward the field, especially on single-dose HPV vaccination. We present our data everywhere where we're invited because we really believe in not just generating the data, but transmitting it outside. We believe in sharing the data, accurate interpretation of the data. And we continue to follow these women for, we're at our 15-year study visit. We believe it's a really important resource for the scientific community. And we do, of course, encourage collaborations. And in a couple minutes, I'll show a slide where people can consider working in our studies. So again, I told you 1980s case control study of HPV. This was not me. I was in elementary school. The 90s. Natural history studies, again, still not me. I'm still a little kid, sort of. 2000s, we implement this Costa Rica vaccine trial. And then I'll talk about some of our new trials that I've launched over the past several years. So what's the design of the NCI Costa Rica vaccine trial? So this started in 2004 to 2005. Again, this is the only publicly funded trial launched prior to licensure, and we'll come back to why that's important momentarily. Women were randomized in a blinded fashion to receive either a Hep A vaccine as a control or the Cervarix GSK bivalent 16-18 vaccine, and then followed 4 years in this randomized blinded phase. 20% of our young adult women received fewer doses. Lots of them were getting pregnant. This was a trial under an IND. We don't vaccinate pregnant ladies when we're determining the safety and efficacy, so they didn't receive all their doses. Lots of women came in and immediately got referred on to colposcopy. So they also we prioritized their screening and their treatment over vaccination. So we do have a bolus of people who didn't get all 3 doses. After the 4-year blinded randomized phase, we had said in our consent, if this vaccine works, because people didn't know if it would work, we would give you the Cervarix vaccine. It worked. We crossed everyone over. And so we knew we wanted to continue to define durability of the HPV vaccine. That became the next question. So we continued our HPV arm, the follow-up, for another 7 years. And now even longer. I'll talk more about that. And we enrolled a new screening-only control group to afford comparisons to afford so we could see what the underlying rate of HPV acquisition was, histology, all of that. And this is the study in which we made this discovery that one dose of the bivalent vaccine might be enough to protect against HPV acquisition and persistence. So I'm going to fast forward. I'm not going to walk through all the data, but this is our most recent cut of the data at 10 years. So this is looking at vaccine efficacy. And I'm showing you here, again, this is the vaccine efficacy more than 10 years since the bivalent vaccine by dose. And there was intervening cuts. Our first paper was at 4 years. And at 4 years, we were like, guys, look, 2 doses work. Like, we were so excited about that. And there's like one little line that says, like, here's a suggestion, 1 dose works. But for a subunit vaccine, or a vaccine where it's not like a live attenuated, but it's just a piece of the virus, those usually take multiple doses. So here's this early, suggestion, but kind of strange. So, which is why we all love science, right? Like, surprises. So this is our vaccine efficacy at 10 years. And so this isn't a cumulative assessment because we wouldn't want the early protection to drive the later. This is what's happening at that point. And so we looked at this among our 3-dose women. I'm simplifying here, the 3-dose women, of which there were a lot, and the 1-dose women, of which there were not a lot. And that's, again, because they weren't randomized to 1 dose, but they got 1 dose only because they had reasons for not getting additional doses. We looked at protection against 16 and 18, which are the 2 types in the bivalent vaccine. And we also looked at what's called cross protection. Cross protection is vaccine protection against phylogenetically related types to 16 and 18 that are not included in the vaccine formulation. So we looked at protection against types HPV 31 and 45. So all vaccine efficacy analyses are really driven by the analytic cohort in which it is investigated, as well as the endpoint under study. So these 2 points, the vaccine works the way the vaccine works, but the analytic cohort in which you look at it and the endpoint that you use drives those estimates. So to kind of make apples to apples comparisons, instead of looking at the absolute vaccine efficacy, we compare it to 3 doses, because now out here, we all know that 3 doses works. And so we want to see how 1 dose compares to 3 doses. We want to think that way. If we're going to go from 3 doses to 2 doses to 1 dose, we want to make sure that it's a non-inferior vaccine administration. So here we're comparing 16 to 16 in the blue bars for 3 doses and 1 doses. Spot on. You do see larger confidence intervals on the 1 dose, again, because of that small sample size. And even at 11 years, we're continuing to see that the bivalent vaccine cross protects against these other types. 1 dose, same for 3 doses. So that was really compelling information. This information is bolstered by our antibody patterns. So the antibodies patterns we look at over time also. So this is the same 1 dose group that I showed you in the previous figure. The 3 dose group, we have year on the x-axis, that's 11 years. And then we have the HPV 16 antibody GMT on the y-axis, note the log scale. So what we kind of expected to see, and this is why at 4 years, when we looked at our antibody patterns, we're like, wow, this is true. Because what we would have thought is like it came up and then the 1 dose would come down over time. But it really has staying power. Out to 11 years, it is durable. And what my colleagues who know more about vaccinology and immunology than I do would say is that once this antibody persists to 11 years, it's highly unlikely that it's going to kind of like fall off a cliff. It could creep down over time, but it should stay relatively flat for the foreseeable future. And here's the 3 dose line up here. And this is a 4-fold difference. 1 dose antibodies are inferior to that of 3 doses. However, what we learn here is that lower antibody levels do not always equate to inferior protection. So really, these 3 dose levels are probably superfluous. And these 1 dose levels, since we saw that the vaccine protection was nearly perfect, it's probably all you need. We're going to keep monitoring these women out to 20 years. Why? Because HPV vaccines, we don't need lifelong immunity. We need someone, if they're having a sexual debut at 15, we need them to be protected optimally through probably at least 25, better 35, to really reduce the HPV attack rate. I am not a perfectionist. So some people will say you need 40 years. We can't do this till you see 50 years. I'd rather make incremental gains. So I'm satisfied already with 11 years. I think, if we can really protect more people for at least 11 years. And again, note this antibody level, like it's not falling off a cliff. So I am pretty satisfied with these data, but documentation to 20 years remains important. So I also wanted to share some of our recent findings. In addition to looking at antibody quantity, which is what I showed you in the previous figure, we look at antibody quality. We look at the binding ability of our antibodies through antibody avidity. And so what we saw is that when we look, and I have a picture of a previous fellow who's now at Merck, she published a paper showing that women who were HPV 16 seronegative at time of vaccination, their absolute HPV 16 avidity was lower in women who received 1 versus 3 doses, but the patterns were similar. So what we really showed in this is that the HPV 16 avidity was strong for both 1 and 3 dose women, but it did differ by her serostatus at the time of vaccination. So one of our current fellows, Dr. Jamie Shing, she's really interested in the concept of unmasking. What is clinical unmasking? And actually her paper came out. I noticed that this one's a little outdated. This recently came out in Lancet Oncology. What this phenomenon investigated is when we think about a woman kind of pre-vaccine, she got HPV 16, and let's say she was co-infected with HPV 35. So she would go on, she'd get screened, she'd have a precancer, because due to the 16, that one runs faster. And so she'd get a LEAP. And a LEAP is a surgical removal of the cervical epithelium. So even it treats that one precancer, but if you have other infections around, it actually truncates those as well. And so now we started to wonder, well, in this counterfactual where 16 is now gone because we vaccinated against it, what happens to that 35 or any of these other infections that we're getting truncated now or not? And so what Jamie saw is that in our vaccinated women, they actually had higher rates of SIN2 and SIN3+ due to these non-targeted, non-cross-protected types. And so it raises questions, and it does not undermine HPV vaccination. HPV vaccination still trumps it all. I mean, there's so much protection there, but it does suggest that after successful implementation of HPV programs, we might start to see some disease from these non-vaccine protected types. I will note that vaccines with higher valency, such as the non-valent vaccine, will further reduce the unmasking potential. Oh, and she won awards for that. I always like to talk about my fellows doing great. We had a visiting scientist from China. Her name is Dr. Shangying Hu, and she was looking at screening in our vaccinated and unvaccinated women. So of course there's been, we know that positive predictive value is very much tied to the underlying prevalence. And when we have 16 and 18 removed or even more types removed, we really expect that the positive predicted value would really go down because the prevalence would go down. These are like our Epi 101. But what Shangying saw, and sorry, this is published in JNCI, I need to update these, is that PPV of HPV testing did not show the expected reduction, the presence of lesions. And so these are a couple of examples, the unmasking, that of the things we can do in this publicly funded data and that has a biobank associated with it that really hasn't been so investigated in the studies, driven by the pharmaceutical companies. And finally, my director in Costa Rica, Dr. Carolina Porras, showed that our bivalent vaccine had high efficacy against 16 and 18 associated precancers for more than a decade. So just to show some data on that, again, we've relied a lot on virologic endpoints because they're more common than histologic endpoints. It's hard to have power to do that. But nonetheless, when we look by time, here's year 0, 1, 2, 3, 4, all the way to year 11, comparing the attack rate of cervical precancer in our HPV vaccine group compared to our control group. And we looked at vaccine efficacy and we looked at cumulative vaccine efficacy. So vaccine efficacy in this first column is in that year, what did the vaccine look like? And then cumulative is at the end of 11 years, how much protection against cervical precancer are we getting? So vaccine efficacy was nearly 100% for all the study years, except for this one in year 4. There was an HPV 16 and 18 associated cervical precancer in the vaccine group. And so that lowered this here. And then when we look cumulatively at the end, I'll draw your attention to the 97%. So what this says, and this is again, target the 16 and 18, this is what that vaccine is meant to do. After 11 years of follow-up, women who received the bivalent vaccine had a 97% reduction of cervical precancer with the vaccine types compared to the unvaccinated group. We do a ton of serious adverse event monitoring. Even though we're not in probably the best position to do it because we're relatively small, but we are a trial. So it's, it's a trade-off. Like, obviously the phase 4 monitoring that the CDC does has a ton more power than we do because it's the United States. But we have a very controlled setting where we're actively querying for adverse events. So it is a trade-off. But basically in this whole list, we see that there are very few serious adverse events in the vaccinated group. And it's similar to the unvaccinated group. So that is our research on the HPV vaccine trial in Costa Rica. As I said, we're at about year 15 of follow-up. We're only following our HPV vaccinated group now because we're only looking at immunologic endpoints as women have reached an age where the attack rate of HPV is pretty low. And so our power was compromised to do virologic endpoints. Remember the figure that I showed you, like slide 3, where it was that green line that speaks up, that goes up, and then comes down. Or now our women are on the down part, so it limited our power. But when you do immunologic endpoints, because it's a blood measure, everyone becomes an endpoint. So we remain well powered to do that. So here's our website if you're interested in talking to us about it. We're always happy. You can request CVT data and specimens. We encourage collaborations with outside investigators. So feel free to reach out, and there's the website. So I'm now going to move on, and I talked about the Costa Rica HPV vaccine trial, which was launched in 2004. We made this discovery of one dose. We've now launched 3 additional trials to really focus in on this one dose question, because we really think this could make the difference in getting the world vaccinated appropriately. So we launched Escudo, which is a non-inferiority trial. Good time check. Perfect. Which is a non-inferiority trial evaluating 1 versus 2 doses of the HPV vaccine. And this is really a cornerstone trial for a consortium of one-dose trials. We also launched Primavera, which is an immunobridging trial. I'm going to show these in a minute, and Prisma, which is a play at acceleration. So this is our Escudo trial. This is a trial we started in 2018. We enrolled girls, 20,300 girls between ages of 12 to 16 years. They were randomized to the bivalent or the non-bivalent vaccine, and then at 6 months had a second randomization to dosing schedule. So again, non-inferiority, 2 doses is our gold standard. The question that we are researching is 1 dose non-inferior. And then we do active follow-up out to 5 years. This also, I lost my train of thought for a sec. Oh, sorry. Okay. This study also has a survey associated with it where we captured data on unvaccinated people, and then we immediately vaccinate them. And the reason that we do that is even though many places in the world, even though the gold standard is 2 doses and we want to see how 1 dose compares to 2 doses, we don't want to be providing inferior regimens. We also acknowledge that the majority of the world is still getting 0 doses. And so we really want to compute that benefit associated with 1 dose. This is our Primavera trial. This is an immunobridging study. What immunobridging does is it takes an efficacy population and looks at antibody levels and then compares that to another group in order to infer efficacy. This is a study design that is often used by FDA and the EMA, the European Medicines Agency, for regulatory purposes. And so in this one, we're asking the questions, are antibody levels induced by one dose of the bivalent GSK vaccine, which is this arm here, non-inferior to the levels observed in an efficacy population? So remember, efficacy was proven for the quadrivalent vaccine in women with 3 doses. And so if the antibody levels in these 2 groups are similar, then we can conclude non-inferiority and infer efficacy. And just a quick, why do we think they will be? Well, the bivalent vaccine is adjuvanted differently than the quadrivalent vaccine, which has a simple alum adjuvant. It gets an antibody boost. Girls compared to women also get an antibody boost. And then when we think of 3 doses compared to 1 dose, the antibody boost, the more robust antibody boost is on this side. But when you multiply out those ratios, we actually think it'll be like a similar antibody responses. And finally, we just put into the field our PRISMA trial. And so PRISMA, we really, there's other people doing 1 dose work. We're really getting confidence about it. I'll share some of the other data in a moment. But once you see that 1 dose works, it how else can we use 1 dose? And of course, boys is an obvious question, as is women. How far up the age scale can we go up and still have 1 dose work? And I'll remind you that Costa Rica, the original CBT in 2004, was where we made this first discovery. So we really think it probably works at least up to the age of 25. So we are in the process of enrolling 5,000 women. They will then get randomized to one of 3 arms: a nonavalent vaccine, a bivalent vaccine, and a control vaccine, which is Adacel. This has virologic endpoints. They'll be seen every 6 months for 3 years. And so if we see 1 dose is even enough up to the age of, I didn't say the age, I'm sorry, it's age 18 to 30. If 1 dose is enough up to the age of 30, and so if we start to put this all together, Primavera, Escudo, that the Primavera started at age 9, Escudo ends at age 16. We've shown 1 dose works there. The whole world is trying to do 2 doses at least, 3 doses if you're over age 15. Suddenly there's a lot of extra vaccine. How are we going to use it? We want to be poised to have the data ready to say, let's go up the age range, because the modeling shows us that even though a lot of these women have been exposed to HPV, it's not for all the types and all the vaccines. They clear the infection. It's not, when you clear natural infection, you don't get a ton of immunity. So there's still benefit here. So we think we can really control cervical cancer faster with this approach. I'm going to just go through a few slides. So I talked about the ongoing studies investigating single-dose HPV vaccination. I just wanted to highlight a few in addition to our work. We work very collaboratively with a lot of these studies. So there's a study that just read out in Kenya. It's the Kenshi study. I have a slide on it. I'll show you in a moment. This was in women aged 15 to 20. The DORIS trial is an immunobridging study. This is actually our formal sister study to Escudo. These are in girls 9 to 14 in Tanzania. There's a trial called the HOPE trial in South Africa. This is not an individual level randomization, so it's really measuring effectiveness instead of efficacy. The novelty here is that they actually have HIV positive women, which is important. And then another effectiveness study in Thailand, and then a study in the Gambia looking to bring 1 dose efficacy through immunobridging down to the age of 4. And these, in addition to kind of the trials that are directly administering vaccination and then looking at endpoints, there's also a lot of regions in the world that are using either registries or other sources to study 1 dose specifically. And here's a map that has some of that. So coming back to the Kenshi trial, this was a trial that took place in Kenya. It randomized 3 arms to either meningococcal, the bivalent vaccine, or the nonavalent vaccine. And then it looked at cervical samples out until about 18 months, although follow-up is ongoing. And so what you see here is time on the x-axis, and then the cumulative incident of persistent infection on the y-axis. This is for 16 and 18. And so what you see is that, vaccination started at time 0. And when they start to measure endpoints, you immediately see these curves go apart. And this is a call out just so you can see it better on right here. The 2 vaccinated arms stay very low, almost nothing. And the control vaccine arm goes up. So at 18 months, the vaccine efficacy for the 9-valent and the bivalent vaccines were both 97.5%. They also looked for the 9-valent vaccine at efficacy against all the 7 carcinogenic types in the nonavalent vaccine and saw efficacy of 88.9%. It's really tremendous. And so this and the body of work that has come together has already incrementally moved policy recommendations. So, most people know this now because of COVID, but in the United States, when something, when there's a new drug or any biological, the FDA looks at safety and efficacy, and then it gets handoff to the CDC ACIP, and they do recommendations. They do all the policy work, taking into account the epi, all aspects of it in addition to the protection. The WHO similarly is like CDC in that it is a policy body. It has a strategic advisory group of experts that does the vaccine recommendations. And what they announced earlier this year is that there's now enough data to provide either 1 or 2 doses for girls age 9 to 14. And they even actually, I think, they're dropping the girls part, and they're just saying all 9 to 14-year-olds, because gender neutral vaccination is really starting to kind of pick up speed globally. I think probably 25% of countries now, at least, provide vaccination to girls and boys. They also, based on the Kenshi data, said you could also use 1 or 2 doses for young women aged 15 to 20. And so this is a great start, in my opinion. I think the ambiguity of the 1 or 2 doses is going to cause problems. I think, what we really have been aiming for is a crisp 1-dose recommendation for girls. And like I said, all women up to 30. So that's really the ultimate goal of our research, but this is a fantastic step. Also exciting is that the UK's JCVI, again, think of it like a CDC ACIP, also put forth a 1-dose recommendation for the adolescent program before the 25th birthday. And the reason this is so important, I think with the WHO recommendation, so many of the high-income countries have rolled out their vaccination programs. They're all multi-dose, a lot of them are gender neutral. It's kind of, it could be perceived that those who are then coming after, like 1 dose is good enough. We don't want to set up that disparity. We want 1 dose for everyone. So the fact that this, JCVI, it's on behalf of the UK, it's a high income country. The fact that they are moving the needle towards 1 dose, I think really, is important globally. So just coming back, NCI, we do a lot of research. Our research is really aimed to generate actionable evidence. We now have trials in the field that start at age 9, they'll go up to age 30. We look at efficacy, effectiveness, durability. Like I said, we provide our data, or we aim for data transparency, accessibility. We share with anyone who's really interested, with proper paperwork in place, of course. And we're also, we want to bring the benefit directly back to Costa Rica. That's really important to us. So we're considering what's the next step. And just to kind of tell you my dream for Costa Rica, much like Australia is really on track to being the first country to eliminate cervical cancer. They've done it using multi-dose HPV vaccine regimens with gender neutral vaccination, really high up in age range, with intensive cervical cancer screening that is top notch. What I think Costa Rica would be great to show is what happens when you use scaled back vaccination with 1 dose, and simplified screening using some of the newest screen and treat methodologies with, 1 or 2 lifetime screens, and really kind of being a model for cervical cancer elimination in a way that's attainable for other countries. So with all the data we're generating, we really hope that in the next decade, we can make huge advances towards controlling cervical cancer globally. So this is our research team in Costa Rica. There's tons of us. I think we're close to about 300 people right now, and I put some of the names of the different groups that we work with. So we also have a robust fellowship program. I just wanted to put a slide up on that in case anyone is interested.